There we go. I'm ready.
All right, hey everyone. My name is Jay. This is Phing Phishers, the talk title as you will, for CircleCityCon. And just a little bit about me. I'm a SIG writer and a malware researcher for the emerging threats team at Proofpoint. I also am a core team member of the OISF, which is the nonprofit foundation behind CircleCityCon signature development. So those guys can have houses and stuff. Traditionally, Emerging Threats has done a lot of coverage and really been known for their coverage of exploit kits. But as anybody's been paying attention, the exploit kit landscape has kind of went away, kind of starting with the decline of Angler and the disappearance of those guys. So lately, I've had a strong focus on credential phishing, which has kind of picked up and filled the void there. About a year ago, we didn't have the best coverage of credfish because it just wasn't that much of a threat. Like EKs were blowing everything up. But now, since the landscape has shifted, it's more important for us to have coverage of this type of threat. If you haven't been paying attention to credfish in like 10 years, not much has changed. There's some new obfuscations, some new things, but there are a lot of better ways that we can kind of detect this stuff. So my talk is basically about making this. Data from the Goonies, making a lot of different tools that work sometimes, are pretty quirky, and kind of get the job done. So everything I'm going to talk about is up on my GitHub. You can download these tools, use them, abuse them, and definitely don't submit any bug tickets because there's no problems whatsoever. So kind of what we're going to talk about, we're going to talk about acquiring source, so the fish kit backend stuff, the PHP code, all that. We're going to talk about why timestamps are important in this. I know if anybody loves forensics, you should probably also love timestamps, and they play an important role here. We're going to talk about the actual analysis of the credential fish, some automation you can do around it, some obfuscations, and then finally writing signatures for this stuff. So you're a scammer. You want to find a new kit. Basically, all you have to do is go to PayPal, or not PayPal, but YouTube, and search for like PayPal scammer, search for eBay scammer, kind of whatever you want. And this is 200,074, then 3 zeros, whatever that number is. Talking's hard. That's a lot. And these guys just kind of abuse YouTube for marketing purposes, and there's a lot of like free stuff you can get here. Alternatively, you can go to a not suspicious at all website and download the backend kits for PayPal, banks, eBay, Amazon. Branding is important. So make sure you're downloading it from a really great site, and then spelling and web design are not of the utmost importance here. But basically, the idea is that all this stuff is out there really easily and can be found. So what they'll do is they'll find a kit, whatever brand they want to fish for. They'll download it. Maybe they get sent it through Skype. Maybe it comes through Trillian. Maybe it comes through AOL Messenger or whatever. They'll unzip it locally on their machine. They'll edit the email inside a PHP file. So basically, the fish kits are, once somebody fills out all the information, it's going to use PHP mail 95% of the time to mail the stolen credentials to the attacker. Then they'll zip it back up, they'll upload it to a server, and then they'll unzip it, and then they're kind of ready to go. So these are a couple examples of some README files, and all of these really miss kind of a crucial step on the part of the attacker. This one's pretty nice from Team PG. They hope it brings you luck. They're very polite. They kind of give you an idea of what to do. This is important for later. That's a pretty unique name for a .php file, and this is a README that's found in their free kits. Some of them are very comprehensive. They can talk about how every page will be encrypted with AES JavaScript, which is really not smart. It's really easy to beat. They won't get detected by AV's toolbars, blah, blah, blah. But this one's very robust. But it doesn't cover the most important part. This one is another one that also is missing the critical portion here. They actually tell you not to do some things like don't delete this folder and don't delete uploads. Does anybody see a step here that they're kind of missing on the part of the scammer and the fisher? In none of these READMEs do they say to delete the archive after you've uploaded it, which is great. Don't. Just keep leaving it there. It's awesome. So on my worst day, on Sunday, there is about a 5% chance that someone will leave behind an archive containing the entire fish kit. When you're eating, thousands a day, this isn't a small number. So what I wanted to do is automate retrieval of this. And there's two main methods that really kind of came to mind of how to find this stuff. The first is obvious, just look at open directories. The second is even dumber than obvious. It's just append.zip to every folder and make a request through. So you have this URL, you strip off nova.php, and then you make a request for void.zip. Then if you don't find anything there, or if you do, you then go to the next folder down, and you just keep going, just keep iterating through the URL. We should also kind of take a look and see what else is in these open directories if we find them. RAR files can be interesting, text files can be interesting. We can't download .php files, but these can be interesting as they can be mailers or shells or whatnot. This tool also does screen caps, and then it does a little bit of hashing on the screen caps to try to help determine known phishing domains. And this is just real simple. Just convert the image to black and white, make it really small, SSDeep it, and then compare it to a list. Not a great way to, it doesn't replace a signature for the kit, but it's something. Because sometimes when you're getting a screen cap, the website might take really long to load, and then you end up getting like half of a screenshot or just a little bit of a screenshot. So I wouldn't say that it's the best way. So we'll just look at a little demo of what this does. So in here is an install file. This is all in the GitHub. Tells you what to do. There's not a lot of setup for it. It gives you all the things you need to install it. It doesn't have a lot of parameters to it. You can either submit a single URL or you can submit a file of line-separated URLs. You can indicate a source, meaning like where you got the URL from, if you like to keep track that way. And then the last thing is you can use a custom user agent if you'd like. Sometimes a lot of these kits will only allow mobile UAs in, so you may want to keep an eye on that. So there's a really great website called OpenFish. If anyone's heard of that, they make a free feed available of just URLs and the brands that are being phished. So I have a file that I pulled down earlier, and we'll just kind of parse through that. So what this is going to do is it's going to iterate through the URLs. It's going to say it's processing this URL, and it's going to basically do the exact same things that I just noted. So it's going to take a screen cap, it's going to save it in the local directory, and then it's going to run through the URLs and try to figure out if it can find an archive existing on the server. So that first one, it found a file by just appending .zip to it. The second one also did the same. There's only a couple URLs in here. Oh man, these are all coming up found. Wow, that's so crazy. It's totally not a curated list of URLs that have zip files available on them. So in this way, I'll kill this. But so now we can take a look. So here's our screen cap. It's named with the year, month, day, time. Came from OpenFish, then the URL. Oops. Fixed it. So this is like a French phishing page. I don't know entirely what cap.fr does, but stealing some information there. Here's a Google Drive or possibly a Dropbox phish, Google accounts, so all the good stuff. So in here we have I'm going to talk exactly about this in like 2 seconds, but basically it goes through and it just pulls down all the things that are interesting. So that is essentially what Buckle Gripper does. So it saves you a lot of time. If you just give it a ton of URLs, it'll just run through all of these URLs and try to pull the zip files for you, and then you can post-process them in any way that you'd like. I'd like to advise against this, making a Twitter bot that would just tweet out like all of these different phish kits and where to download them from. There's kind of already a lot of free places to get this stuff from, and I mean, do it if you want, but I've usually pulled down about 150 to 300 unique kits per day, and I'm happy to provide those zip files to anyone that has like a project or a non-commercial type of deal where they could utilize that information. This is pretty much what a usual day looks like, just a lot of fish kits. And not all of them are interesting, so that's kind of what we'll get into. So what am I doing with these? The biggest thing I'm doing is writing emergent threat signatures with them. Looking at the encodings that are being used, the backend PHP, looking at metadata and timestamps to help understand what's going on, what's new and what's old. A lot of reporting, and then archiving all of this stuff for the dirty metric word and various later things. So here's an example of a landing page. This is the PHP backend code. The first thing that is usually up here is some kind of block list. So it's like an IP list or UA block list, which is always bad. What they do is they grab a random number in a really weird way. You don't need that last number there, but and then this is just a function to copy all of the fish files of this kit into this newly created folder. And then they just shove the user to this newly created folder. So many kits do this. It's basically to get a unique folder for each visit. Has anyone seen any really obvious issues with this? Like, what can you do knowing that this is occurring? Are they blocking like any IPs from hitting it multiple times? Oh, yeah, you just spam it. And I mean, how long would it take to fill up disk if you just hit it with like an HTTP stressor or whatever? I'm not doing that, but what we can do is we can write. You know, the VMs are cheap these days. So this is what it looks like in Wireshark if we hit one of these types of pages. The big interesting thing here is this location of the hash. So when they redirect you down here, the location, the folder name is just a hash, which doesn't really happen all that often. So what we can do is we can write a emergent threats signature, or a snort or Suricata signature. This is really simple. It just says if there's a 302 status code and there's location, and the location is a MD5 hash, alert. This could be a possible phishing redirect. So pretty simple. On the flip side of that, when the person is finished and they've given away all their credentials or they've posted in lots of bad words to insult the scammer, they come to this page where this is actually doing the PHP mail back to the user. So you can see that they have 2 email addresses in here because redundancy is important. And they are sending this from Apple, customer-support@spammers. So you could look at that in your mail logs because if you had mail going out from one of your web servers, that could be interesting. They have 2 separate mail statements here. Usually there's just one. You can see they've set the send variable to these 2 addresses that appear unique. 419, we can guess what they're doing and where they may be from. But usually if there's 2 mail statements, one of them may be an indicator that there may be a backdoor in this kit. And the author might have included a PHP include somewhere else that has their email address in it. So that's commonly what happens with all these free kits. They've also chosen to make text backups on a compromised server. Always a good idea to keep all your credit card numbers that you've stolen around on somebody else's hardware. And then there is a redirect at the very bottom. This is the most important part. So the user has gone through these pages, they've given away their information, and they'll be kicked out to this website. We can write a signature based on this activity too. So looking in Wireshark, this is all fake data that we'll get into how that's generated later. This is the post body. So this person has entered in their email address, their password, and their phone number to view a file. And then we get kicked out, we get 302 to adobe.com/reader. So what does that look like in a signature? So it's really easy. But in writing IDS signatures for Snort and Suricata, you can't write a signature that encompasses both of these. The red is the request, the blue is the response. But you can use something called a flow bit. Now, a flow bit just says, if I see something weird in this first part, set a marker, and then anywhere else in the TCP stream, if that marker is set, I can write another rule that will only fire if that marker has been previously set. So that's basically what we're doing here. We're saying we're looking for an HTTP post with email and pass following email. And if we see that in traffic, we're going to set a flow bit for just like a generic fish. Like this, and we can't alert on this because this is super common, and it doesn't always indicate phishing. So what we'll do is we'll tell our flow bit to not fire on this, like just be quiet. And then we'll write a second signature that's really easy to read. It looks more like this. So basically, it looks to see if that flow bit has been set. If it has been set, then the rest of this rule will execute. If it hasn't been set, the rest of this rule will not be processed. So we're looking for a 302 with a location, HTTP, and then we have just this regex is just a ton of different websites that are commonly phished. Like you can see American Express in there, Amazon's in there, Microsoft is in there, FedEx, Facebook, all sorts of things. So we can get away with this because this signature, while it looks super gross, won't actually run unless the first one is set. So we kind of cut down the amount of traffic we're looking at before we actually execute that. So that actually works out really well, and we get a ton of hits on this because that's the most common thing to do after the phish kit is over is they kick you out to a legitimate site. So the next part is finding encodings. Some of the encodings that are in use, we see AES a ton, implemented in JavaScript. It's probably one of the most common ones, but it's also really easy to beat. We see data URIs used, which happens to come up on Twitter like every 8 or 9 months. Somebody's like, data URIs are a big deal. We're all like, no, they're not. JavaScript and escape encodings, which are really common. We see different variations of base64, like backwards base64, some XOR and some custom stuff. There's a white paper down here that I did a while back that has all these in their entirety. But we'll look at one that's more kind of more interesting. So initially, this is a phishing page, in case you didn't know. They're using a data URI at the top here. And if you didn't know to look at this first part, you would just say that, oh, this is adobe.com. And my version of Adobe Online has failed something that doesn't, it's not a thing. That wouldn't cause Adobe to fail, but you need to log in. So if we look at the HTML source, we can see that they're using a nested base64 data URI, which is how they get the top the browser bar to display. So this is, they do one refresh for a data here, and then they have a whole bunch of spaces, and then this first data URI is closed down here, so all of this in the middle executes. So if we click OK, then we're sitting here. Pretty decent PDF fish. And it's got like the background, which kind of looks like the online Adobe viewer and whatnot. Okay, not bad. If we look at the decoded content of all this, it's just Edwards Packer, which is super common. Can't really write a signature for that because it's used for good stuff and bad stuff. There are some interesting fields at the bottom that we might be able to write a signature on. But decoding that, we get this part. So we see the window title at the top, and then they're actually using an iframe down to actually display the login page. So without knowing any of this website I went to isn't, if I did a takedown for this or whatever, it wouldn't actually get the real site. So this is good on the part of the attacker. If I go to that site and visit the iframe that comes up, we see this, and we have some really basic HTML encoding, JavaScript, an escape. Decode that, and we can start to see the alert. So this is the initial alert that fired. Your Adobe Online has failed, rest. And it's nice. It's like they're doing some jQuery, some JavaScript stuff, and then these guys aren't utilizing normal HTML posts. They're using jQuery Ajax type of stuff. So this is a pretty well done fish. Another one. To me, this is more interesting. So this is the first section of a page. If you looked at the source of this HTML page, this is the first thing you'll see, and we'll just kind of take it step by step. So this looks like hex code, which is eval unescaped, comes out to be this, which is weird. So we eval, then we unescape. We unescaped this code, and then we evaled it, in which they've set unescape to a new function. So they've rewritten the functionality of unescape. Don't worry about what all this means. It's kind of doesn't matter for this example, but they've renamed all of the variables hashes and whatnot. If we look at the second part of it, it's another eval unescape. If you looked at this initially, not knowing that the first unescape had different functionality, you might be like, why? You can't unescape this stuff. That's not going to work. It's going to error out. At the very bottom of this, blurring it out for just the important part, like this is just this, and then you have a script at the very end. What does this look like? You have an array that kind of goes up, and then it's like an associative array. So making a key. So what they do is this is a custom encoding, kind of just silly, like kind of CTF type of encodings. But this works pretty well and it kind of bypasses a lot of security measures and whatnot, so it won't fire. If you decode it with this key, you'll get something that looks much more like the actual HTML page. And then this is just HTML decimal, so you can decode that. and that'll be that. So those are some interesting encodings that I've seen. There's a lot more. Just don't have time, and they're on that white paper. My slides will be up afterwards. I want to talk a little bit about timestamps. If you're not in forensics, you probably don't care about timestamps, but I super care about timestamps. So when you pull down a zip file, or when you make a zip file, all of the files within the zip, they keep their timestamps. So they don't change no matter where that zip is copied or anything like that. Once you unzip it, you'll see when those files were last modified or created. And we can use this knowledge to kind of determine two things. One would be like the deployment age. So we could take the newest PHP, HTML, whatever, file inside the archive, subtract it from today, and we could say that this kit was last modified or deployed at like 7 days ago, or 150 days ago, or 3 years ago. And that gives us some valuable information. We can also determine what I'd like to call a relative age, which is just subtracting the date of the newest HTML or PHP file inside of the archive from the oldest one. And this, combined with the deployment age, will give me some more information about if this kit is interesting or not. So if I have an archive that has a high relative, meaning that there's a big delta between files within the zip file, and there's a very low deployment delta, this probably just means that it's an old kit that I'm looking at, and it's probably not interesting. So all of the files were changed at the same time within it, and it was deployed just recently. So I wouldn't really look at that. If I have an archive that has a low relative and a high deployment, that means that it's just old, and all the files inside it were modified around the same time. If they are both high, then I don't care. But if they're both low, then that's really interesting, because all the files are modified around the same time. They may be new files, and it's been recently deployed. So what I'll do is all of the fish that I'm pulling down, I have a post-processing script that will essentially look through that and say, these are all the kits that have a low relative and low deployment. So this is one that's not interesting because it has a high relative. So the files in here, this is like a Google Drive fish. This stuff hasn't been modified since 2014, but we can see that March 10th, the verification.php was modified and the index.php was modified. Probably this includes the email address that the Fisher updated to make sure that it goes to their information. But one that does look more interesting would be this. And setting aside that they could just simply copy all these files and make a new timestamp here, this is usually the case. This will be more interesting. This will be a newer fish kit. So this is something for CenturyLink, and they have all their archive files here that were changed around the same time. But then the login.php, finish, and index were all kind of modified around different times, and you can get an idea of how they were updated and what time. So they had it for a few hours before they deployed it. So to me, as someone looking into these, that's interesting. Moving on to PDF files. So normally we see the fish links come in emails, but I also see a ton of links come through in PDFs. These are super common to find on VT and hybrid analysis. And they can be kind of annoying to have to open the PDF and find the URL inside of it to add it to my processing. So I wrote a little script to basically dump out all the links that are in clear, and also to go through all of the streams and dump out all of the URLs in streams. So we'll take a look at that real quick. If anybody has any questions, feel free to shout them out. Five, I think. It's my dad's favorite movie. All right, so I have a folder here of just some nice PDF files, things that might get sent to your users. Please don't, things you tell them not to click on that they're going to click on. So if you did something like, let's say you used like Suricata or Bro and you were cataloging all the PDF files that came across, you could dump them all into a folder and then run a script like this. Which would essentially just pull the links out of here. This uses Didier Stevens' PDF parser, a great Python tool, to go through all of the streams and pull this out. All you do is just give it the location of the PDFs where you stored them, and then it'll spit out the URLs from all of these different PDFs. So some of these PDFs include more than one URL within them, and some of them don't actually start off with HTTP, which is something I used to use to find the links within the PDFs. But just a simple script to pull that out. It's really useful if you kind of keep all the PDFs that cross your network around, and you can just do that every day and then utilize that as intel for what's going on in your network. But don't forget about docs. This is kind of a weird one, but I don't know, people do weird stuff. This is an actual Excel file, so it's not a phishing page yet. And then your file is secured. To view the complete one, click here. Like, first thing comes to mind is like Dridex, all of the stuff that's going around right now. JAF, all sorts of macro-based PDF. But this is just a fish PDF, so they've sent an actual fish PDF. If you kind of look through it and grep for strings or for HTTP, you don't find it in there because it's an XLSX, which just means it's a zip file. If you unzip it and grep through there, then you can find the URL at the bottom. And what they do is they redirect you to an online Excel viewer. Once you've made the sale, dude, stop selling. Like, you already got them to click the XLS document, but they wanted to redirect you out here to steal your credentials. So that's something important too. Don't forget about documents. So from the researcher, SOC analyst, network engineer perspective, I've talked to a bunch of people and kind of like got an idea of like, all right, what do you guys do with like fish URLs when you find them? Like, what's your general process? And the process, it sucks, like to the point where they don't do it. But you find the fish URL, you start up a VM, you spin up Wireshark in there, and then you go and visit the landing. You enter in some fake information. Hopefully the kit isn't checking for like valid information. A lot of times there are JavaScript validators on them. You click, and then you enter in some more fake information in the next page. You got to make sure you're using a one-validated credit card number because they check for that stuff. Click again, enter in your fake information. There's been lots of times where I get like weird banks where I don't know like what sort codes are in like Asia or Asia Pac or anything like that. Like, they have just very different things, so I'll end up spending a lot of time figuring out what those numbers actually look like. Click again, stop Wireshark, review the PCAP, look for zips, and then, this is a big process. This kind of sucks. So I did this probably 50 times a day when I was starting out, and I was like, we don't have very good coverage of fish at ET, and this is not sustainable. I wrote a lot of signatures, but once I started hitting duplicates, it was just terrible. So I was like, oh, I'll just automate it. That'll be great. I can't do this talk without showing the most true XKCD article to me ever, and it's essentially what you think automation is going to be like, and then what it's really like. And the alt text is automating comes from the roots auto, meaning self, and mating, meaning screwing. So this is how I screwed myself. So what this next script does, Bully Blinder, is it basically automates that whole 14-step process. It uses some really basic techniques to do form filling, handle cookies, redirects, refreshes, JavaScript, utilizing mechanized Selenium and Python, a lot of Python. It's best on the majority of phishing that's going out right now, which utilizes like typical HTTP posts to send credentials and HTML forms to have your input structured. Utilize Firefox, and the general goal of this isn't to really make life harder for scammers. It's to make life easier for me in writing signatures and whatnot, and to make sure that we have better coverage. But if entering a lot of fake data, makes somebody's life more difficult, then cool. All of the scammers run all of their credentials and whatnot, stuff that they find through like validators, anyways. So the only thing that I think is really helps out is if you have credit cards that you're entering in, and you enter in like one-validated credit cards with like an expiration and a CVV that looks good. There's not a really good way to find out if that's legit or not because it'll validate. They actually have to either sell it or use it to determine whether or not it's real or not. Bully Blinder relies on a really cool Python library called Faker. And this is just, when I found it, I was like, thank God this exists. But basically, you can say, like, give me a fake name, give me a fake email, give me a fake phone number from this locality, give me a credit card number of this type, MasterCard, Visa, whatever, an address, an apartment. It'll just generate all this fake information for you based on whatever you ask for it. So let's take a look at a demo of this. So again, there's an install file that it's pretty much the same files as Buckle Gripper. But we do have an AES Python script in here because we see AES a ton, and it's just easier to convert that out than it is to pop Selenium for every AES encryption we find. The 10k.txt is a password file, so it's just 10,000 common passwords because I want to enter in passwords that look somewhat unique. I don't want to enter in things that just look like garbage. So I'll usually every couple of months I'll go through and say, okay, who got dumped? Who's the latest dump? And just update this with 10,000 passwords or whatever. So what this does, some of the arguments here, you give it a single URL. You can change the user agent if you'd like. The default user agent is like the most common Windows 7 one that's around. I've definitely seen kits that block on user agents, so they won't even allow like Mac or Linux to take a look. All they really want is Windows. Fine with me. And then an interface. So this will utilize T-Shark, and as you're going through and doing the form filling, it's going to make a packet capture for you. Oops. I think that was the name. So like this, I can read in. I have a commit. I just haven't pushed for reading in a list of files. Oh no. So this should bring it in. Did I name it something different? Let's just look at one of these. So what it'll do is it'll prepare a PCAP. It'll say it's processing it. We'll scroll back through all this information too. It looks kind of garbage because the font's big so you guys can read it. But it'll go through, it'll hit the first page, look for the form, and then it'll continue going through until it finds something. So it hit an error that it didn't, that the last part wasn't a document, but we still have the PCAP. So if we take a look at the PCAP, we have a get, so this is the caf.fr. We can see that this was made by Jason Bourne. Crap, we're screwed, guys. But so this is the fish landing. See, that's the login page. This is one of the ones that we looked at initially. It's from the same feed. And then we have our post here. So you can see kind of what this looks like. So we filled this in with some fake information, and some of it's good, some of it's not. We don't have it's not smart enough to know what a province is. So if it doesn't know what a form field is, it'll just enter in like some business jargon, because I think that's funny. But a lot of the stuff is through here. So we have the email, swilliams@hotmail.com, a password of Scream, and another probably a check password. But so we have all this information here, and then it kicks us out to the actual real page, caf.fr. So that worked there. Let me do one more. And then in the output here, let me do a different one. Let's do this one. This is the fish for Blackboard. Sound effects. All right, so this is a shorter one, a little bit easier to read. So we made the PCAP, we processed that URL. It's showing you what the form looks like before it actually makes the post. So it's made a user ID of KBAC, a password of weapon, and then it submits that through. The next page that it hits is actual www.blackboard.com, which it knows to be a legitimate website. So it considers the fish done, and then it spits out the URL request chain. So, no Jason Bourne on this one, that's good. But this is the Blackboard site. We can see the title there. Scroll down. There's a whole bunch of stuff here. A lot of things that, if I was looking for the form, this might take a few minutes, but whatever. Just let the script do it. And then we have our post. So this is exactly what we saw on the other side of the script. Just the user ID of KBEC was submitted, weapon, and now we have a PCAP that we can utilize. We can run this through our security tools, whatever, make sure that we're covered. If we had a user that had actually clicked on this before, and we can write a signature for this to determine whether or not this happens again. And then they were kicked out to the real Blackboard website. So kind of just some more examples of what this looks like. This is a really common Google Doc phish. If you click on one of these different service providers to give away your information, it looks like it makes a pop-up. But if you look at the HTML code, it's actually, the form is on the first page. So the script would go through, it would look at that page, it would scrape that form, and it would do exactly what we just saw. So it'll post that information, and here's what it looks like in Wireshark. Some of them get more complicated than that. A lot of times they don't give you the form just on the first page. This one, if you click any of the brands to enter in your information to view this document, you get a pop-up window. That's slightly more interesting. And if you look at the code, they use the JavaScript pop-up window to do that. And the script is smart enough to see that and then process the pop-up instead of being like, well, I hit the page and I didn't see a form, so I don't know what you want me to do. It'll keep going through that. This is the redirect that we saw initially earlier, just showing that spits out the same information. This Apple one is a little bit more interesting in that we hit the first page, there's a form on there, cool, so we fill the form. We hit the second page, and it's, oh, no time. So we have AES encryption through JavaScript. But the script, again, is smart enough to be able to process that. So we hit the first page, we find a form, no big deal, we submit it off. We hit the second page and see an AES encryption, we decode it, and then we fill the information in here. And this is kind of what I'm shooting for, and there's probably more work to be done on this, but making this information look as real as possible is pretty cool. So I've sent them an actual fake generated credit card number with a name, a CVV, an expiration date that all looks kind of real. Date of birth that doesn't look so real, but it's got a social security number in there, so who could resist? And then you have the URL request chain at the bottom to kind of tell you like where it's gone. So there's a lot of trial and error here. It's taken a lot of work to find all of these different redirects. I'm not going to go through all these, but these are just some of the things that occur, like JS top.location redirects are a way to kind of break spiders and whatnot that may not be able to parse JavaScript. Bitly, Twitter, Cloudflare all have these warning pages that pop up, and they're like, "Hey, you might be clicking on a fish page." I'm like, "Yeah, I want to click on the fish page." So you have to bypass those. A lot of interesting stuff. So some of the newer kits utilize jQuery and Ajax. It's not the norm, but I definitely expect it to go this way more often than not. It's just really a threshold of talent for people to develop kits that don't utilize just a dumb HTML post. Sometimes there's more than one post on a page. So like there could be a search bar at the top, and that could be, we don't want to submit a search, we want to submit the form that's after that. So we have to do some trickery to get around that too. The countermeasures, they always utilize a UA block list, and sometimes it helps them, but it's really easy to get around. IP block list, same deal. Just don't be on the block list. They block list things like Amazon, EC2, a lot of security companies. Just do it from a VPN. They block, a lot of them block Tor. Do it from any of the decent VPNs that you think one of these guys might use, and you're golden. They're not going to block themselves. So just do that. Mobile UAs, I don't really have anything in place for that. It's kind of hard to. You'd have to make that first request and then see. Okay, no, I got denied probably because it's looking for a mobile UA. Something I'm working on, but something that's not in there too. Geolocation. If you have something, a modern VPN service, you can have lots of exit points. So you can set this up to determine locality first, and then send it out the right exit point. A lot of times I'm looking at this stuff and I'm like, my script is just garbage, it's not working. I pull it up and I look at the page and it's like a broken form. Like they didn't include like an an end bracket, or they didn't like properly quote something or whatnot, so it doesn't actually work at all. So if they would, do proper coding, that'd be a lot better for me. Just small request.
So Phishers, please improve your code.
Stop being bad at code. A lot of times there may be misconfigurations. Sometimes if you're hitting a phishing page that's been up for a little while, the hoster or the owner of the page might have taken down part of it. So like they deleted like the backend PHP script, which actually sends off the information to the scammer, but they don't actually delete the landing and whatnot. So just think as you run through this stuff, sometimes it's not always the script, it's not always you. If you wanted to do this kind of stuff, there's no reason why you can't, but just be smart about it. Use a VM. There's no reason an exploit couldn't sit on a phish landing page. We definitely see instances where they will include a keylogger or some kind of Trojan after the phish. So they're like, well, we got your credentials. You're probably going to be dumb enough to download and run this too. We see that a lot, but we don't see like an EK phish like all in one, which I think would be cool. So do that. If you're running this stuff, don't use your work, home, or personal IP space for obvious reasons, and really just don't be a doofus. So the last part I want to talk about is kind of writing the IDS signatures for this kind of stuff. We covered a couple of them already, and just a couple examples. So this is a pretty common DocuSign phish that we see. Again, it's like the multi-select your email provider. That's great. This title jumps right out. And because I acquire so many phish kits, and I'm pulling out all the metadata, I can go through and look and see, all right, how common is this title over all the kits that I've grabbed? And it turns out it's pretty common. So we can just simply write a signature that just looks at the title, and it's just HTML decimal that just says DocuSign. And we can write a signature just based on that. Another landing here. If we look at the source code, there's some things that you wouldn't expect to find in a Google Drive normal page. So you can write a signature just based on some of the content in the page. You don't have to make it super fancy. This stuff will still run very well on a sensor. We can pull out the fields that we think are important and interesting, and then kind of go from there. The landings are kind of the lowest severity, so they aren't real interesting. I really want to help out SOCs and analysts that are looking at this stuff and be like, hey, somebody lost their credentials. This is an interesting thing, like go start your investigation type stuff. And that's what this is. So this is kind of personalized to the organization. Like it'll look at the email address that they've submitted to you. So when they send you the link, they'll include your email address in the link, and then based on whatever the domain is in your email address, they'll say, this is Bob's Shoes or whatever. And then they'll pre-populate your information in here and whatnot. So looking at this initially, we see this hellion.php. Well, I know what that is. That's Team PBG, those guys. So I can write a signature just based on seeing a post with that in the URL, and then content of pass. So looking inside of the HTTP client body, I'll add that in there to make sure it kicks off a couple of false positives. We can also write a signature based on the content of each of these arguments inside of the HTTP client body, and that ends up looking something like this. They also include email equals in the post request, so this is like a personalized. They're looking to phish someone specifically. So we include that, and then we can say that this is a personalized WA webmail phish. Just using all of these forms. These are just easy. These are super easy SIGs to write. We're not doing anything super crazy. It's really common for these guys to host stuff on free domains, like Hostinger, or any of the millions of companies that seem to think that they can make a business model based on free stuff. So this one will basically look at, we see that they're using 16mb.com, which is one of the Hostinger free domains, and then they get kicked out to match.com after they've entered their information in there. So what we can do is we can write a signature based on that. So just say post, username, pass, and then utilize a regular expression, everybody's favorite thing ever, to just only fire on domains for the Hostinger free domains. And that makes things very easy there. Sometimes they're smart and they do things that make sense. So this is Outlook Web App. This isn't like a weird one like the one back here, like where you're like, that doesn't look like WWA. And then they're asking for kind of things that you would expect to see. They've also included like super weird things as their parameters. So I have no email equals, I have no pass equals in here. And just looking at this, this looks like somebody typed this, like purposefully. Like it looks kind of like they're using, I don't know, if I was just typing random stuff on the keyboard, this might be something that I enter in there. So I know that I can't use those parameters as parts of a signature. But the page that they're redirected to, which is this OVVA, maybe that looks like OWA, but it's not. It's two V's. Don't be fooled. Is just loads up with this, and then this will redirect to Office365.com. Why don't you just redirect in this page? I don't know, but this is what we're doing. So I can write a signature based on this subsequent landing page, because the only way that someone would logically get here would be to enter in credentials, because they're not going to go directly to ovva.php. So I can utilize this information right here as a signature. And we just utilize the content of this page, so this meta refresh, Office365.com, and then this title of account success. This shows up for like no time, so what's the point of even having it here? I mean, thank you for the free sig. But so this is what that would look like. So there's the successful OWA fish based on the server response to the request, and we can write up a signature that way. So those are a lot of the common things that we deal with. I'm working on adding many features to these scripts. If anybody has ideas for these, I'm super open to them, as well as other related scripts. You can, there's no Pinterest apparel here yet. There's no Bully Buster, but there will be. I also have a site, Fish Total. It's not, there's nothing there yet, so don't even bother. But my idea is I want to make a public website where anyone, similar to, Virus Total, you can submit a URL or a PDF file, and we can do this kind of automation and do a similar thing to Virus Total. I'm also working on a phishing framework, think like SET, but for defenders, where you can essentially handle notifications, have a backend database, everything like that, so that you can, anyone that's interested in kind of doing this type of work can do it and share it with others through like MISP or any of the other information sharing frameworks. So that's pretty much it for me. Does anybody have any questions about this whole thing?
What was the most challenging part of hammering
the encodings, the different handling the different landing pages and trying to figure out what is actually part of a template and actually what's part of like a one-off, like somebody just tried to do something different to be interesting. But definitely going through and finding all the different encodings and getting the script to actually make the HTTP post when there's no actual form on the page. That logic is somewhat long and complicated. I'm sure if someone else did it, it'd be way better, but I'm doing it, so that's it. Thanks, though. Any other questions? No? All right, well, thank you very much. I really appreciate you spending the afternoon here, and I hope you guys have a great rest of the conference. Feel free to come grab me if you want to talk about anything afterwards. Thank you.